Hi, this is a basic introduction to the Mephisto EX, also known as the Extreme, supplied by Sample and Hold, the official service partner for 4D Dynamics. By the end of this video, and with the aid of the manual provided by 4D Dynamics on the install CD, you should be able to set up the system, calibrate and scan. We're not going to go into huge amounts of detail in this tutorial, but it should get you on your way. We're aiming to create several more videos over the coming months, including calibrating for the turntable and using some of the more advanced features. If we don't produce these videos fast enough, the manual is a good source of info, and anything that can't be found there or isn't understood can be answered through the forum. Okay, so we're going to start with the initial setup of the system. I should point out now that although the video is for the EX system, it pretty much applies to all other systems available through 4D Dynamics, including the introductory Pico system. They're all based on the same underlying principles and code. I should point out that we run some older hardware, so some things may look different from the more up-to-date systems that you may have. I'll make sure to point out what to do where these things differ. If you do get stuck or I miss something, refer to the manual or fire an email to support, or better still, go to the forum. Some other people may have asked that same question, or if they haven't, you can ask it and others can benefit from that. Okay, let's get started. Stage 1 is the initial setup. So this is roughly what your system will look like. As I mentioned before, your hardware might be slightly different, but the same principles apply. Start with the power cable and plug it into the projector and the mains power supply. We'd advise getting a voltage regulator if your mains power isn't stable. Next is the VGA in. On your system this is likely to be a blue color to match the port on the back of the projector. Plug it in and make sure everything is screwed in tightly. This applies to all the fixings we're about to go through. Loose connections can have a dramatic effect on the data captured. Plug the other end of the cable into the VGA in on the PC or laptop. You may need a VGA to DVI converter if your PC or laptop only has a DVI connection. It's fine to use one. Next is the sync cable. Plug this into the AVT camera. This can be a little fiddly. Place it up to the camera and rotate, applying a little pressure. As soon as the pins match the holes, it will click into place. The other end of this cable is a second VGA head. This plugs into the VGA out of the projector and is usually black in color. In our case, we don't have an out on our projector, so we plug it into a little converter. But in your case, you'll probably be plugging it into the projector. The Firewire 800 cable plugs into the AVT camera and into the PC. And finally the USB into the Canon camera and PC. O2 Start a new project. Once installed, you should find a desktop shortcut. Double-click this to launch the software. Click either the New Project shortcut button or go File, New Project. So we're going to create a new project starting by giving it a new name and a directory where we want the project to be. Don't put this directory in the C program files Mephisto EX, as this can cause problems. Best to place it in a folder directly on the C drive. Next we choose the Firewire camera. Click the radial to select it and choose from the drop-down. Unless you have more than one Firewire camera, there is only going to be one choice here. We do the same for the Canon camera. Make sure you have it turned on. In the projector settings, choose Screen 2. We want the native resolution of the projector you have. The preload radiometric data will probably be unticked in your case. We'll go into more details about that in another tutorial, but make sure it's unticked. Set up the calibration pattern as we have. Square size 18 mm. This matches the size of the squares on your calibration board. Leave thickness as it is and click Finish. The software will then switch to the processing window. In the bottom right corner you'll see the live inspector. Stage 3 is geometric calibration. The first thing we're going to do is check a few settings. The first area to look at is the firewire camera. This should be set to HDTV mode on the EX. The online configuration settings represent the projector, and each projector requires different settings. The Canon camera setting dialog will only show and allow you to change the relevant settings if the camera is set to manual. Now click on the calibration tab at the top. If we go down to the live inspector, we can double click the bar above it to tear it from the sidebar, and you can now resize this window. Once you've done this, adjust the AVT camera sets pointing at the calibration board, which should be placed around 1 to 1.5 meters from the camera and positioned between the camera and projector. Double click the live view bar and it will redock to the right. If we go back to the settings tab, we can change the idle pan to help us focus the image. We prefer the focus image, but some like the checker pan. It's entirely up to you. Now head back to the calibration tab and open up the live view again. We're now going to adjust the zoom and focus of the projector. Check the projector instructions if it isn't obvious how to do this. We want the projected image to be just a little bigger than the height of the board squares and for it to be in focus at its center. We're now going to point both cameras at the calibration board. Using the live view, we're positioning, zooming, and focusing the AVT camera so the calibration board fills the view. We're looking to fit the board in as best as possible with maybe a 5 to 10% margin top and bottom. This comes with a little practice. By right-clicking in the live view window, you can get a picture-in-picture style digital zoom. By scrolling the wheel on your mouse while holding the right mouse button, you can adjust that zoom. This is a very helpful feature when trying to focus the camera. As you can see, the live view shows the effects of adjusting the focus and aperture rings on the camera. We're looking to get the image in focus and for the aperture to be neither over nor underexposed. Red in the live view means overexposed, blue underexposed. When calibrating, if you have to make a choice, go a little over rather than underexposed. Okay. Just a little tip. If you click the red X and close the live view, it will disappear. Don't worry, head to the top bar and right click and put a little tick next to the live inspector and it will reappear. Double click on the bar and it will pop back down to the right. Okay, next thing is to click Grab Calibration Frame. You'll notice the projector flash a couple of times. Once it's done this, you should see 3 green rectangles appear in the software that represent the calibration board. These should all have numbers next to them that represent the total number of corners captured. It's good practice to click on each section to make sure everything is in order. When you click on each one, the image of what was captured will appear to the right in the image inspector. To help see the results of the capture, click on the image in the image inspector window to the right. The zoom window will appear. If you then go back to the green rectangle and right click, a drop down will appear. Select the options, while calibrating there is only one, and look back at the image inspector. You will now see how the software has located the corners on the squares. We want to check that none of these markers are anywhere other than on the corners of the projected image on the flat surface of the board. The same applies to the texture camera. You can see here that there are 2 problems with the texture camera. First, it is underexposed. This is denoted by the blue color you can see. Second, it is not framed correctly. The software is pretty robust and still managed to get excellent results. However, if you left the camera like this, you'll have texture matching issues later. Okay, so the first thing we're going to do is sort out the exposure. Go to the Settings tab and Canon Camera section. TV denotes shutter speed and AV aperture. We're going to reduce the shutter speed to 1/3 and set the aperture to f/22. We're making the shutter pretty slow because if we run it too fast we might end up seeing the effects of the color wheel in the projector. We want the aperture to be quite high so we have a good depth of field. Once we have the settings we think are about right, head back to the calibration tab and grab a frame to check the results. In this case it's still a little darker than we'd like, so repeat the process until you get it right. You're looking for an image that isn't over or underexposed for the calibration. Next we need to align the camera. Do so by unlocking it from its head. You want to align it so the image you see through the viewfinder matches or is a little more zoomed than the image in the live view. Once you have it lined up, focus the camera. We find it easiest to switch the autofocus button on the camera lens on, half pressing the shutter release button on the camera and then setting the autofocus button back to manual. It's very important to put it back to manual. Also turn off any stabilization if your lens has it. You should find this button near the lens focus button. Grab another frame to check everything looks okay and that the images of the calibration board in both the Live Inspector and the Image Inspector roughly fill the same volume. At this stage it's easiest to reset the calibration process, now everything is in order, so we can start with a clean sheet. Position the calibration board square on and perpendicular to the rail that the projector and cameras sit on. Press the Grab Calibration Frame button. That is your first set of calibration images. Now move the board and grab another frame. The aim is to fill an imaginary volume with the board using several angles. Keep an eye on the software while you're doing this to make sure there aren't any issues. If there are any, they will manifest themselves in the form of a red marker in one or more of the columns. If this happens, move the board to a new position and grab a new frame, unticking the row with the red marker. It's not advisable to capture two frames of the board in the same place either. If you do this by accident, untick one of the rows. When you have captured between 5 and 12 images and unticked any bad ones, click the button Calibrate System. It may take a couple of minutes to analyze the information collected, depending on the speed of your PC. We're looking to get an RMS value of between 0.2 and 0.6. The manual goes into a little more detail about what this means, and we'll produce another video in the future which touches on the more advanced aspects of the scanner. But for the time being, just know that between 0.2 and 0.6 is good. Once you get the results, it's a good idea to save the information so if anything happens we can reload it. When you do your first save, do it via Save As and put it in the calibration folder in the project you set up. O4 Radiometric Calibration. The radiometric calibration is a way of measuring the amount of light the projector outputs over its full range of intensities. It's really important that when you do this calibration, it's done in an environment that doesn't have a light source that changes over time. Pretty much all standard lights flicker, often faster than we can see. However, this alteration will be captured by the ABT camera and will therefore have an effect on the results of the scanner. We'd recommend doing this calibration in a dark room. The great thing about this calibration, though, is that you don't have to do it every time. The more you use the scanner, the more the bulb in the projector will wear, and the more you'll have to do this calibration. But realistically, you should only have to do this once a month or so. In the Calibration tab, go to the Radiometric tab to the left. Place a white piece of paper on the calibration board, making sure the center of the focus image is near the center of the piece of paper. Whatever you do, don't move the camera or projector individually, as this will break the geometric calibration we have just done. Best at this stage to move the board and white piece of paper. To speed up the learning process, change the number in the projected intensities to 12. We'll put this back to 52 later. Now at this stage, if we go ahead and press the Grab Calibration Frame button at the top and wait, you'll see the projector pulsing. It is outputting 12 intensities between its darkest to lightest output, and the camera is recording this information. As you can see from our live inspector, the image is very blown out. This is to demonstrate what you don't want to see. If you find that the plotted dots top out on the graph or don't cover a good range, then you will need to adjust the aperture on the ABT camera. Be careful not to touch the zoom or focus ring, as this will break the geometric calibration. Once you have what you think is a good balance of light and dark on the white piece of paper, press the Grab Intensity frame again and wait. You should get a better curve. If not, adjust the aperture again. Once you have a nice curve, change the projected intensities back to 52 and press the Grab Intensities frame button for the final time. In the future, once you have an understanding of the process, you should be able to gauge the exposure of the camera and do this in one go. You'll see a much more detailed curve appear. Next, press the Compute Intensity Compensation button. Some figures will appear. We're interested in the last percentage. We want to get somewhere between 60% and 85%. If that is the case, press the Use Intensity Compensation button. The next button is not a necessity, however it does give you an idea of what the system is doing. Press the Grab Frame to test compensation to see how the software takes a non-linear curve of projected light and adjusts the output to make it linear. To speed up this process, we have changed the sample intensities back to 12. Save the project. This time you can either press the Save shortcut or go to File, Save. O5 3D Scanning. So the calibration is done. So long as you don't adjust the zoom or focus on any of the components or move them in relation to one another, you can use this calibration. We'd advise, though, if you leave the system for an extended period or aggressively move the unit, that you do a new geometric calibration to be on the safe side. Now head back to the Settings tab and adjust the 3D acquisition mode's vertical grey code to 8 bits. Change the subpixel method to 6x60 and set the pattern quality to standard. In our case, we set it to enhance. Next, press the Create Pattern cycle. It could take several minutes to complete this. You'll know it's done when the projector flickers. It's a good idea to save after you've done this to speed up restarting the project later if you need to do so. Unless you have external flashes connected to your system, untick Use external flashes instead of projector. Okay, we're now good to scan. We recommend scanning the calibration board first to confirm everything is as it should be. Place the calibration board so that it is in focus using the projected image to help you. Adjust the exposure of the AVT camera, not too dark, not too light, and then hit scan. Wait a few seconds and the calibration board should appear. It's a good idea to rotate around the board to make sure it's flat. If it isn't, something went wrong with your calibration and you will need to redo it. If you head down to color mode, you can adjust the way the captured data is rendered. Normals is probably the best method for viewing the data, as it shows up any irregularities. Shaded is a standard orange shader. Low-res texture shows the texture information captured by the grayscaled AVT camera. If color texture capture is important to you, it's a good idea to compare this low-res texture with the high-res texture to make sure they align correctly. Switch between the two and do a visual comparison. Draw mode shows the data as points, wire mesh, or as a filled model. If at any stage you lose your model or want to zoom out quickly, press the shortcut key R. To view or remove the grid, press G. To save the model, you can just press the Save Model button, and it will save with a generic name, sequence 01.ply for instance. Alternatively, you can add a name to each scan or group of datasets, however you feel best suits your workflow. The given name will precede the sequence number.ply part. You can choose what information you want to save with the data, for instance color per vertex, UV coordinates, normals, and faces. Note that when choosing a format, it should be one that can encapsulate the choices you make above. For instance, OBJ files cannot hold color per vertex. Currently the software will not warn you of this. It will just save out the data with the options you choose that are available for your chosen format. There are two types of save. The first is save frames. This is a bit like a backup, as from these frames and the saved project file in the format .mpl, we can rebuild the data and apply some adjustments. Think of this data like taking pictures with your digital camera in the RAW format. The second option is Save Model. This saves the data in the chosen format using the Format section. From here you can scan your objects. Make sure you make the correct adjustments to the aperture of the AVT camera. In our case, the elephant is quite dark, so we open the aperture by one stop and scan. Notice there is a lot of background data being captured that we don't want. You can remove this going to the Reconstruction option tab in the Processing window and changing the max distance to a lower number, say 1200 mm. This represents the distance from the sensor of the AVT camera to a virtual plane where any data behind it will be removed. Go back to the Scan Options tab and press Scan again, and you will see the background data has disappeared. As you can see, the elephant doesn't fit in the view the way we have set up the system, so we will have to manually align each scan to create a full 360 model in our processing software. The data that you have captured can be found in the location that you set at the start of your scanning session. In our case, C drive, Mephisto EX, sample and hold demo 4. In this folder, the software creates 3 more folders for you. When we saved the project for the first time, we did so in the calibration folder. It is here that you'll find the .mpl file that holds the calibration information and settings. The processing folder holds the raw images, which are stored when you press the Save Frames button. Finally, the reconstruction folder holds all the geometric data in the formats you chose. Take a look at our website if you're interested in seeing what you can achieve with the Mephisto system, including the elephant data. As I mentioned, we'll be producing more videos shortly going into more detail. If in the meantime you have any other questions, please post them on the 4D Dynamics forum, and we'll do our best to answer them as fast as we can. Using the forum also means that others can benefit quickly if they have a similar problem or question. Cheers, and good luck.